In this video, I'll be helping you with the ALEKS problem type called using trigonometric functions and the formula d equals r times t in a real-world situation. In this example, we have Aldo and Bill standing 105 meters apart, indicated on our graphic here, and they're both looking up at a roller coaster as shown below. One of the cars of the roller coaster is moving at a constant speed of 4 meters per second. The car is currently located directly above Aldo, and the highest point on the roller coaster is directly above Bill. The car begins to ascend towards the highest point on the track at an angle of 32 degrees. So I also have this angle, 32 degrees. Find the remaining distance, r meters, that will be between the car and the highest point after 12 seconds. So after 12 seconds, it will be about here, and we want to find the remaining distance to the highest point. Carry your intermediate computations to at least 4 decimal places and round your answer to the nearest tenth of a meter. I'm going to approach this problem in 2 pieces. First, I can use the trig functions to determine the length of the hypotenuse, and from that I can start to find the remaining length here, r. And since I'm given this 32 degrees, I've already got the hypotenuse here labeled since it's the side across from the right angle. From 32 degrees, this would be the opposite side, and this would be the adjacent side. And since I'm given the adjacent length here, 105 meters, the trig function that has both the adjacent and the hypotenuse, remembering SOHCAHTOA, the ka part here, cosine, is equal to adjacent over hypotenuse. So in this situation, I can write that as the cosine of our 32 degrees is equal to the side adjacent to that 32 degrees, which is 105 over the hypotenuse, which I'll just call h since we don't know what the hypotenuse is. But from here I can solve for the hypotenuse first by multiplying both sides by h to get that h out of the denominator. And then to get the h by itself, I can divide both sides by the cosine of 32. I will have the h by itself, and I can turn to a calculator here to do this calculation. 105 divided by the cosine of 32 degrees, plugging into Desmos 105 divided by the cosine of 32, and confirming that our calculations are being done in degrees, gives us this measure, which I remember there were some instructions about intermediate calculations being rounded. Looking back at those instructions, we can see that we were told to carry intermediate computations to at least 4 decimal places. So 4 decimal places would be here. Since it's followed by a 3, I'll drop those remaining values. So we now have the length of the hypotenuse in meters. So that total length for the hypotenuse is 123.8137 meters. But recall that we are only looking for this distance, r, the remaining distance, after the car has been traveling for 12 seconds. And this is where we can use that formula d equals r times t, distance equals rate times time, because at this point, we know the rate is 4 meters per second, and the time, it has been traveling for 12 seconds. So those seconds cancel, and our distance traveled here will be 4 times 12, or 48 meters. So we now know the total length of the hypotenuse, and we know this distance is 48. To find the remainder, we can just subtract. The remainder would be the entire hypotenuse, minus the part that's already been traveled, and these are both in meters. Doing that subtraction gives us 75.8137 meters, but we were asked to round our answer further to the nearest tenth of a meter, so our final solution for that length r will be 75.8 meters as the remaining distance after 12 seconds.